Alright, here we go with lesson 13. We're going to be performing arithmetic operations on polynomial functions. We actually did this before with quadratics and linears, so this should sound pretty familiar. So to get started, let's take a look at these three functions here, f of x, g of x, and h of x. And your goal is to answer these three questions. What is the value of f of 1 plus g of 1? What is f of x plus g of x? And what is the value of g of h of 1? Okay, so if I look at f of 1 plus g of 1, what I'm thinking about here is that I need to find first the value of the function f when x is 1. Then I need to find the value of g when x is 1, and then add them together. So I can actually write these all out. Let me color code them. I'll do f in white. So what will f of 1 be? All right, well, let me write an equal sign here. I'm finding f of 1 plus g of 1. Well, f of 1 will be 1 cubed plus 12 times 1 squared plus 20 times 1 plus 24. What about g of 1? Well, I'm adding it to whatever f of 1 is. I'll put this in parentheses just to remind myself I'm adding all of it. And it will be 4 times 1 squared minus 15 times 1 minus 10. So what will this all equal? Well, I can simply go ahead and evaluate this expression. And so after evaluating both of these expressions and adding them together, I'm going to end up with 36. So that's the value of f of 1 plus g of 1. What about f of x plus g of x? Well, here I'm doing the exact same thing, except x hasn't been evaluated yet. I haven't plugged in anything for it. So I want to leave it just in terms of x. But I'm doing the exact same thing. I'm taking f of x, and I'm adding to it g of x. I just need to keep everything in terms of x. So as you can see here, I have f of x, and I'm adding to it whatever g of x is. Now I could leave it like this, but notice I wouldn't have it completely simplified. I can add some like terms together. So I'm going to still have an x cubed all by itself. I have 12x squared plus 4x squared. It's going to be 16x squared. I have 20x minus 15x, which is going to give me 5x, positive. And I have 24 minus 10, which is going to be positive 14. So notice here that if I take f of x and I add to it g of x, no matter what the x value is, I will end up with that x value cubed plus 16 times that x value squared plus 5 times that x value plus 14. Notice that this is just another function. It's the function that I get when I take f and I add g. And we've seen examples of that before. What about the value of g of h of 1? Okay, well notice here that the first thing is that I've got to figure out what h of 1 is, because I can't evaluate g at some value. I can't plug in anything for x into my function g until I know what that is. So I've got to first figure out what h of 1 is. So I'm going to rewrite this. I'm going to take g of, and I've got to figure out what h of 1 actually is. Well, there I'm just substituting 1 into my function h. So that's going to be negative 4 times 1 plus 1. All right, well I can evaluate that pretty easily. That's going to be negative 4 plus 1, or negative 3. So I'm taking g of negative 3. Well, I can also evaluate that pretty easily by plugging that into g of x. Go ahead and do that now. You'll end up with 71. The big thing to notice here is that what I did was I used one function to find the input value for another function. This is what's called a composition. So let's go ahead and take down some of the key points that we discovered here. All right, so here are the key points. Functions can be added, subtracted, multiplied, and divided. Simply apply the correct operation and combine like terms to simplify. So like I added f and g in part B of the discovery problem, I could have subtracted them. I could have multiplied them together. All I have to do is apply the correct operation and then combine the like terms to simplify. The last part C, is what's called a composition. So functions can have another function as its input. This is called a composition. That's what we saw. The input of one function is replaced with a whole new function. Okay? So let's take a look at an example. Okay, so let's say I have f of x, which is x squared plus 2x, and g of x, which is 3x. If I compose the functions together, meaning I make one of them the input for the other, in this case, I'm taking g of x, and it's going to become the input for my function f. So whatever g of x is, it will now be my input for f. So this is actually surprisingly easy to write. Notice that what the function f does is it takes its input and squares it, then takes its input, multiplies it by 2, and adds those two together. So when its input is g of x, or 3x, I'll be taking 3x, squaring it, then multiplying 2 times 3x, and adding those two together. So I can rewrite this function as such. I have 3x squared, all of it squared, plus 2 times all of 3x. Now I can simplify this a little bit. When I take 3x and multiply it by itself, I get 3 times 3, which is 9, and x times x, which is x squared. So I'll have 9x squared. And 2 times 3 is 6, so I have 6x. And so this is f of g of x, 9x squared plus 6x. So if I wanted to plug in a value into this function, I could just plug it straight in here. I don't actually have to plug it into g first and then evaluate it at f. I've already done that for any x value here, and that's my function. All right, let's go ahead and apply these to a couple of situations. All right, so here you have f, g, and h, three functions, and your goal are to find the following. The first, f just evaluated at 3, g evaluated at 3, then f of x plus g of x, make sure you simplify, g of h of x, or g composed with h, and 2 times g of x minus h of x. One tip here. Go ahead and take a look at the examples that we just did as a little bit of a help, or the discovery problem as well. And for part E, remember that you have to multiply before you can subtract. So make sure you do that. All right? You should have all of these ready to go so we can discuss tomorrow and then move on to some more complicated but more interesting examples.